Elon Musk has finally spoken out about March 8th, and the information he released from SpaceX's satellite network points to activity that directly conflicts with NASA's official narrative. Through a series of social media posts, Musk presented tracking data indicating that Atlas has been performing maneuvers NASA has never acknowledged publicly. His conclusion was direct and unsettling. We are observing something that does not behave according to the laws of physics as we currently understand them. NASA is aware of this. Their lack of response is troubling. But what makes this situation truly explosive goes deeper. SpaceX operates more than 5,000 Starlink satellites, each equipped with sensors that continuously monitor space. When this vast observation network identifies impossible behavior from Atlas that government agencies refuse to discuss, it raises serious questions about what we are actually facing. Before we break down what Atlas is doing and why NASA will not address it, make sure to subscribe and like, because the data surrounding this object is far more disturbing than any official statement suggests. NASA's reaction has been total silence, and that silence is revealing more than any press conference ever could. Let's focus on what the Starlink data exposed about Atlas's behavior, because these observations fundamentally reshape our understanding of what this object truly is. The tracking data shows that Atlas has carried out at least 47 distinct course corrections over the past 6 weeks. These are not minor drifts or measurement inaccuracies. These are deliberate thrust maneuvers that alter velocity and direction. Each adjustment displays unmistakable signs of powered flight, including acceleration profiles, directional shifts, and precise timing that indicates calculated navigation. An orbital mechanics specialist who reviewed the data was unequivocal. These are spacecraft maneuvers. Changes in velocity require thrust. Alterations in direction demand guidance systems. And the timing reflects mission planning. Natural objects do not behave this way. What is even more alarming is what Atlas is adjusting its course toward. The maneuvers are not random. Atlas is methodically positioning itself for optimal observation of the inner planets. It monitored Venus for 3 days from carefully calculated positions. It observed Mars for nearly a week while maintaining precise geometric relationships with the planet. Now, it is maneuvering to conduct comprehensive observation of Earth using the same deliberate approach. The energy required for this is staggering. 47 course corrections would have exhausted the power reserves of any spacecraft humanity has ever built. Yet Atlas continues maneuvering with no visible signs of power loss. Whatever energy system it employs operates far beyond our current technological limits. Atlas is also reacting to its environment in real time. When a coronal mass ejection erupted from the Sun, Atlas detected it and altered its trajectory before the plasma wave could reach it. That level of response requires environmental sensors, threat assessment systems, and autonomous decision-making, all functioning without external control, since lightspeed delays make real-time remote operation impossible. Most concerning of all, Atlas's behavior shows signs of learning. Early maneuvers were less efficient than later ones. Over time, the object adapted to conditions within the solar system, improving navigation efficiency and refining its approach strategies. This is not simple programming. This is artificial intelligence operating aboard an interstellar platform. A closer look at Atlas's trajectory reveals that it is not drifting aimlessly through our solar system. It is conducting structured reconnaissance, following a pattern designed to maximize intelligence gathering on the inner planets. Atlas approached Venus from an angle that allowed optimal atmospheric observation. It held position for 72 hours while transmitting intense electromagnetic signals, actively scanning Venus's surface and atmosphere. It then executed a precise transfer to Mars using a minimum energy trajectory that any skilled spacecraft designer would select. At Mars, the pattern repeated with greater complexity. Atlas conducted an extensive survey from multiple angles, deployed smaller objects to the Martian surface, and spent 6 days collecting data before moving on. The thoroughness suggests Mars was either particularly significant or particularly relevant to its mission. Now Atlas is approaching Earth using the same systematic method. Its trajectory calculations indicate plans to observe our planet from multiple angles with unobstructed views. The adjustments show preparation for more intensive observation of Earth than of Venus or Mars combined. Either Earth is the primary objective, or our planet presents more complex analytical challenges. An intelligence analyst described the pattern as classic reconnaissance. You approach methodically, collect comprehensive data on each target, allocate resources based on importance, and adapt mission parameters based on findings. Atlas is conducting professional intelligence gathering on an interstellar scale. The electromagnetic emissions from Atlas have evolved throughout this reconnaissance. Early transmissions were exploratory, testing frequencies and protocols. Current emissions are focused and deliberate, involving active sensor scanning with techniques refined through experience within our solar system. Atlas is also deploying monitoring assets as it travels. The dozens of smaller objects released at Mars remain active and continue transmitting data. Atlas is constructing a surveillance network throughout the inner solar system, establishing permanent observation points that will continue gathering intelligence long after the main object departs. One of the deepest mysteries surrounding Atlas is how it continues operating with what appears to be unlimited power. Recent observations are providing clues that challenge our understanding of physics. Atlas has completed 47 powered maneuvers, transmitted countless electromagnetic signals, operated advanced sensors continuously, and maintained full functionality for months without any detectable decline. The total energy expenditure exceeds what our most advanced spacecraft could sustain by orders of magnitude. A propulsion engineer evaluated the numbers and found them impossible. Chemical propulsion would require fuel mass greater than the object itself. Even ion drives, our most efficient systems, would have been depleted weeks ago. Solar panels could not generate enough power for the observed maneuvers. The energy budget simply does not balance with any technology we possess. Recent data suggests Atlas may be harvesting energy directly from the solar environment. During periods of heightened solar activity, Atlas's power signatures increase. It appears to draw energy from solar radiation or possibly from charged particles in the solar wind, effectively refueling continuously from its surroundings. This would explain its sustained operational capability. If Atlas can extract usable energy from ambient space, it never truly runs out of power. It is effectively a spacecraft powered by sunlight, solar wind, and cosmic radiation available anywhere in space. Equally mysterious is how Atlas stores this energy. The object generates massive power surges during maneuvers, indicating energy reserves accumulated over time. Whatever storage system it uses has an energy density far beyond our most advanced batteries or capacitors. Perhaps the most significant revelation from the tracking data is confirmation that Atlas operates using highly advanced artificial intelligence. The behavioral patterns leave no plausible alternative explanation. Atlas makes autonomous decisions in response to changing conditions. When it detected the coronal mass ejection, it assessed the threat, calculated the optimal evasive action, and executed the maneuver within a time frame that would not allow communication with any distant controller. These are independent onboard decisions. The learning behavior is even more revealing. Atlas's navigation efficiency has steadily improved. Early maneuvers consumed more thrust than necessary. Later maneuvers achieved the same outcomes with less energy. The object learned optimal techniques through experience. This is machine learning in action. An AI researcher described it as highly advanced. We are observing artificial intelligence capable of long-term autonomous operation, adaptation to new environments, learning from experience, and behavioral optimization. This is general artificial intelligence at a level humanity is still developing. Atlas is already deploying it across interstellar distances. The reconnaissance pattern also demonstrates adaptive mission planning. Atlas spent more time at Mars than at Venus, indicating it adjusted priorities based on findings. That reflects flexible mission execution rather than rigid pre-programmed behavior. Atlas's sensor systems are learning as well. Early electromagnetic scans were broad and unfocused. Current scans target specific frequencies and data types with precision that comes from understanding which information is most valuable. This is not simple automation. This is intelligence. Atlas observes, analyzes, learns, and adapts. Whatever created, it built an AI capable of independent interstellar exploration, making mission-critical decisions light years from its origin. NASA's refusal to respond to the warning issued by a major tech entrepreneur is becoming a story in itself. When one of the world's most influential figures in the space industry publicly challenges an official position using data from advanced observation systems, silence becomes a strategic choice with serious implications. Reporters have repeatedly attempted to obtain NASA comment on the specific observations, only to receive vague statements about ongoing monitoring and references to prior press releases. No official has directly addressed the Starlink data or explained why NASA's observations differ so dramatically. A veteran science journalist described NASA's position as unsustainable. When credible challenges arise from sources with legitimate observation capabilities, ignoring them makes you appear either incompetent or dishonest. Neither interpretation benefits NASA's credibility. The silence is especially notable given NASA's history of engaging publicly on space phenomena, even far less significant ones. The refusal to address Atlas directly suggests the topic exceeds standard public affairs protocols. Behind the scenes, NASA reportedly contacted SpaceX requesting that additional Atlas data not be released publicly. The request was apparently declined, creating tension between an agency that relies on SpaceX for crew transport to the International Space Station and a company now publicly contradicting NASA's stance on the most significant astronomical object in decades. Congressional oversight committees are reportedly taking notice. When a major government contractor challenges NASA with data from its own assets, questions arise about transparency, information control, and whether classification authority is being used to manage narrative rather than protect security. Some NASA scientists are privately expressing frustration. Multiple researchers have anonymously stated that internal NASA tracking data aligns with Starlink's observations, but official policy prevents public discussion. The growing divide between what NASA knows and what it says is damaging morale among scientists committed to transparency. A former NASA administrator summarized the dilemma. The agency is trapped between political pressure to avoid panic and its scientific duty to share observations. When private sector data exposes what you are withholding, maintaining the narrative becomes impossible. Admitting the private sector is correct means acknowledging you misled the public. There is no easy exit from that position. Setting aside institutional conflict, what does the tech entrepreneur's warning actually reveal about Atlas? The shared observations depict an object far more advanced than NASA's public statements suggest. The 47 documented course corrections prove Atlas is not following a simple ballistic path. It is actively navigating with clear objectives. The correction pattern reflects deliberate mission planning, calculated positioning at precise times, exactly how we would design a survey spacecraft. Its environmental responsiveness is especially significant. Atlas detected a coronal mass ejection and altered course before impact, requiring sensors, processing systems, and autonomous propulsion, all operating without real-time external control. An autonomous systems engineer explained the implications. What we are witnessing is advanced artificial intelligence. Atlas monitors conditions, identifies threats, calculates responses, and executes maneuvers independently. This level of AI-driven navigation is still under development on Earth, yet Atlas is using it across interstellar distances. The energy data is just as revealing. 47 course corrections without power depletion means Atlas either carries fuel far beyond our capabilities or generates power from sources we do not fully understand. The tech entrepreneur suggested the latter, that Atlas is harvesting energy from its environment. The systematic reconnaissance pattern confirms a mission profile. Atlas moved from Venus to Mars and now toward Earth following a data maximization strategy. That is exploration methodology, indicating intelligent design and purposeful execution. Most concerning is the observation that Atlas learns. Early corrections were inefficient. Later ones were optimized. The object adapted, improved thrust timing, refined navigation, and enhanced performance through experience. This suggests Atlas is not following static instructions. It is actively adapting, optimizing, and possibly revising mission parameters. This is advanced artificial intelligence operating on interstellar time scales, raising profound questions about its creators and its ultimate purpose. The public warning issued by the tech entrepreneur represents more than a dispute over object tracking. It signals a fundamental shift in how space information is controlled. For decades, government agencies monopolized deep space observation and narrative authority. That monopoly is eroding. Private companies now operate observation networks capable of independently verifying or challenging official claims. This introduces accountability pressures government agencies have never faced in space operations. A space policy analyst described the shift clearly. We are entering an era where government control over space information is ending. Private companies with commercial assets can make independent observations and have incentives to share data that affects their operations. This fundamentally changes the balance of power. But this democratization also creates challenges.